So if you want to basically read the information, you can use select command. If you want to add any new records, right? That's where the second command comes in, insert. If you want to change any existing records or existing information, that's where you have update command. Okay. And if you want to remove anything, any records, basically from the tables, that's where you can use delete command. Okay. So total 7 commands. And if you master these commands, you can do pretty much anything with the database structure. 80% or 90% of the thing. There are other commands which are more advanced commands, but these are the main thing that you can use day to day for your development, for the manipulating the data, querying the data, or dealing with any database structure and so forth. Okay, so let's see. So let's come back here. Okay, so as I said, so you have those 3 commands here for the data definition language for manipulating the, not manipulating, but any creating, dealing with the database structures. Okay, and then create. You guys remember the CRUD? CRUD. It's a create, read, update.
Yep.
Okay. Yeah, in the Airflow document, if you recall that, you probably will see the CRUD operations mentioned in some of the design documents. So it's nothing but create, read, update, and delete. Okay. So for those operations, you have 4 different commands. So for creating the data, you have insert. R means reading, or retrieve. It's a select. Update is update, and delete is delete.
Okay.
So that's where those that CRUD comes from. Create, read, update, and delete for the data side of things. Okay. So now we know certain basic commands. So let's see how we can use this command to deal with our stuff. So for our purpose, right? First of all, right now we only have a software. We don't have anything else, right? So what we will need is we need the database first, right?
Okay.
Within the database, we have to create the table structure, and then only we can manipulate the records in there. So what I'm going to do is I'm going to fire up my SQL Server Management Studio. So if I do SQL on my machine, I will see SQL Server Management Studio 18. Depending on the version you install, you will have the similar things. So let me open that up. And SQL Server Management Studio is a tool that allows you to interact with the database engine that you have installed, or DBMS software. Okay.
Okay.
Now here, what it will do is it will ask you for server name, and it should pick up your computer name here. But if you don't have it, and if you don't know your computer name, so you can always put local host to connect to the local SQL Server engine, database engine.
Okay.
And leave the Windows authentication, because what happens is when you install the SQL Server, it will automatically makes you admin for the SQL Server. And this one just says you are logging in as whatever user you are on the machine. So you will have admin access to this SQL Server. But if you have, you can set up the SQL Server authentication separately as well, where you can specify the username password in the SQL Server, and then you can use that to access here. Okay. But for now, our purpose, we'll just stick with Windows Auth and click connect. Okay. And here, first time when you open it, you may not have any databases, and I don't have anything here. I think you will have the same thing on your machine.
Yeah.
So on the left side, so this is a server we connected. Then you have n number of databases. Okay, so that will be organized under this databases folder, and you can expand collapse here. This plus and minus, this is expanding and collapsing. And let me go over quickly other items as well. So this is the main one for our purpose. But then you have security. So if you have add any users or anything like that, you will add those users here. But we're not gonna worry about those things. Those items, security management is an administrative task,
Okay.
typically done by the database administrator and so forth. So you don't normally deal with security for as a developer or as a QA or anything else. Okay. Other items, replication is again a management. So if you want to replicate, you have to set up replicate between multiple database instances. Then you
Mhm.
can set up the replication here for that. High availability you can manage and so forth. Okay. So other stuff you can pretty much ignore. This is the one that we will focus on. All right. So right now, if I expand it, I don't have any databases here. So how do I go about my writing the SQL statements, right? That's all because we need to create the database using the SQL statement. So what I will do is I will go here in this menu item here, and it says new query. Okay. So I will click on that, and it will pop up a new window. This is where you can write all your SQL statements in this window, and you can execute it as well. So first of all, what we need is we need to create a brand new database called patient registration. Okay, so here is the simple command is create. It's not case. These commands are not case sensitive. So if you type it in something like that, it will still work. So here, what we are saying is create. Now, what type of structure you want to create? That's what you want to specify here next as part of the syntax. So here we are creating a database. So I'll say database, and then the name of the database. So here I'm going to say patient registration. Okay. So the syntax Y command, then the structure name. Okay. Structure name, and then the actual name of structure. Okay. So that's what we are giving in this format. It's a pretty straightforward syntax. So if I have to create a table, right?
Mhm.
So all I have to do is I would say create table and whatever the table, like patient table, something like that. So create is a command to what type of structure and the name of the table. That's what we are saying here. Now create table has a little bit more, so we'll come back to that. So now if I haven't only typed in, I haven't executed yet. Okay,
Okay.
so that's the reason I'm not seeing anything on the left side. Okay, so what I need to do is I need to once I type in the command, and I need to execute using this execute button. Okay, so once I do that, it says command completed successfully, and my database is created here. Okay, so if I look at on the left side, I still don't see anything. The reason is that as soon as you execute the command, it's not going to refresh your left panel. Okay, so
Mhm.
you have to manually refresh it by clicking on the folder and right click and say refresh, and then you will see your database created here.
Okay.
Okay, and now I have my database. I can expand it. Now I can see my different folders here, which is a tables folder. And if I expand the tables folder, I don't have anything because I haven't created any tables here. Okay,
Okay.
um, so that's the reason I don't have it. Now, if you remember here, my database says registration, right? So I had a typo here. So what do I do? So best thing I can do is I'll say delete, drop patient registration database patient uh, registration, right? Because I had a typo. So what I'm going to do is I'm going to wipe out, and I'll run that command. Okay. So here I have multiple commands. If I want to run only this command, right? So I just select that, and then I can execute it. Okay. So it will run only this particular line.
Right.
If you want to run this command again, you can just select that line and execute, and it will run that. So here, what I'll do is let me correct the name here. Patient registration, and I'll say execute. And Now, if I come back here on the left side and I refresh, now I can see correct database name here. Okay.
All right.
So what I did is I just used two different commands for manipulating my databases, database structure. Okay. Any question on this one? Commands or the tool here?
I don't have a question.
Okay, Bismarck,
Yeah, I'm good. I'm good.
you good? Okay. Well, what I want you guys to do is let's work through this small exercise because you're gonna need the database.
Mhm.
So let's go and create the database. Then you can use a drop command to drop it and then recreate it at the end. Okay. So
All
that
right.
will give you some basic understanding of the commands and the tool. And in the booklet, in the material, if you want to follow through the steps here, you have on the page number, I believe 3, right? So there is an
Right.
exercise here. You can follow the same steps. Now here there is a go statement here, right? It's a go is optional. It just like executes a batch of commands, basically, separates out. So if you have multiple commands and you can put the go statement in the middle, so it will execute the top one first, then the second one, and in the batches. But
Okay.
ignore the go for now. You don't need it here. And then how to delete. So you have delete command there as well, and so forth. So just quickly work through that exercise, maybe 5 minutes.
Mhm.
See if you can open up if your database is working okay and so forth.
With our own words or what?
Yeah, you have to open the management studio on your machine, right?
Yeah.
So you type in SQL and hopefully you will see the SQL Server Management Studio. I think you already have it. We checked yesterday, so you should be good. And let me know once you are done, okay? So that way we can move forward.
I mean, I'm done.
Okay.
Yeah, I'm done too.
Okay. So you both should have patient registration database, right? Here on the left side, you should be able to see it. If you don't see it, make sure you refresh it and you have this patient registration, which will be empty. Okay. So right now we don't have any tables, views, or anything else created. So we'll work through that process next.
Okay.
All right. So let's move on. Okay. All right. So before we dive into the actual table creation, so table has a few things here, right? So table, so if we come here, so table has a fields, and fields has one more item, which is called data type. Okay. So every field you will have some type of data type associated with it. So let's understand what the data types are available in the SQL Server, and then we can see how we can come up with the fields for field types and naming and so forth for every table. Okay, so let's understand data type. So there are commonly used T-SQL data types. So T-SQL is again a SQL specific to the SQL Server, but it has its data types. Now Oracle is very similar, but Oracle it might be called number instead of integer and so forth. But that's something varies a little bit between the database database software. Let's talk about the T-SQL one. So obviously we have numbers, right? We can store the numbers and so forth. So there are several different data types available for storing the numbers. So number meaning like a sequence of 1, 2, 3, 4, 5, 6, 7, something like that, values that we want to store in the table, in the one of the fields. So first data type is the begin. Now this thing varies, okay, based on the range that it supports. So the smallest range you can see is a bit, is the smallest one. You can either store 0 or 1. Those are the only two values you can store. Okay, bit data type. There is a tiny int which stores up from 0 to 255 values only. So that means if I have a 256, my field needs to support, I can't use tiny int. Okay, then you go up here to the small int, which is a small integer value, and it supports negative 32,000 to up to some positive 32,000 number. That big of a number it can store. Integer is obviously negative 2 billion and to positive 2 billion. And big int is, I believe it's a trillions or whatever this number is called, to 63. So it's the largest number you can store in the big int. Decimal is again numbers, but it allows certain decimal points. So it's, you can store it, use the decimal to specify the format of the storage as well. So you can say, okay, I want to store up to 3 digits or 4 digits, something like that. If you don't want to do it like that, you can just simply say float data type, and it will store any decimal point, any digits after decimal point, basically in the decimal values. Okay, so that's decimal and float, which allows decimal values both. So think about, let's talk about the patient. Let me pull up the table here. So let's say assume the social security number is all numbers only. Okay, this is numbers. So for social security number, what type you can pick from here? What would be the most appropriate type for social security number?
Bits. Oh, I'm sorry. Tiny. Is it tiny int?
So social security number, think about how many, how big the value can be. So format is something like that, right?
I'll stick with int. Tiny int, I think.
So tiny int only allows 0 to 255, and your number is this big. So how many digits are there? Social security number, right? It's 1, 2, 3, 4, 5, 6, 7, 8, and 9.
9. Yeah, so bits would be fine then.
No, bit you cannot store. Bit only allows 0 and 1, 0 or 1.
Oh, okay.
Yeah, so you cannot store more than one number. So I cannot store 2 as a value in the field. So for storing this bigger number, so social security number can be starting with this one, right? Minimum would be 9 ones.
So int?
Actually 10, yeah, 9 digit, right? 3,
yeah.
3, and 3. 299999999.
Okay, so then int should do it then.
Right, int. So you have to look for it, right? This one is also not possibility small int because it's only up to 32,000 values. So this one is bigger number, right? So you come here to the int, and yeah, okay, it allows probably 10 digits. 1, 2, 3, 4, 5, 6. Yep. So this one, this value they can store both of these values, minimum and my. So does the big int as well, right?
Okay.
But social security number probably will not go beyond 9 digits, so int would
Yeah.
be appropriate, and so forth. So that's how you decide what data type you'll be allocating for picking out for a field, specific field.
Okay.
When you have to create the data type, data tables, and so forth. Now for legal first name, right, and so forth, those are alphanumeric, but patient ID can be um, as big as this number depending on what you are storing or how big your number is, right?
Mhm.
Or because this one is kind of like infinite, this number can be, it's like a whole population you can store in the data in that particular field.
Mm.
If you have all the patient, it will still not run out of the patient ID number. Okay. All right. So
Right.
does it make sense how we pick out these things? And
Yeah.
what's the difference here, right? It's a
Yeah.
range. That's what is the difference. Now, why do we go through this exercise? Because as you increase the range, it requires more storage for storing the values in the database. Okay. So if I give big int instead of int, yeah, both of them can store this number, but I'm still picking out int because it requires less storage. Okay, because otherwise every time, even if I store value of 1 in this big int field, it will still take 8 bytes or 16 bytes instead of storing like 4 bytes in the big int field. Okay, that's the reason you want to pick the right uh, data types so that you minimize the storage as well. Okay, all right, so let's move on. Okay, so date and time. So if you have to store date time values, you can use either date or date time, um, those things. So the difference here is date does not have a time component. Date time will include the kind of like a 12 a.m. or 12 p.m., something like that, as part of the date format. So it will allow to store that. So think about for our case, let's see, we are identifying the birth date, right? So these are the only dates only. So we can either pick date data type or date time data type for
Mm.
that, and allocate the field over there. Okay,
All right.
so that way um, it will work for the table. Okay, and we'll come back to that get date function a little bit later once we die. I think in this third chapter or second end of the second session. Okay, so for storing the alphabet, all alphanumeric values like legal first name, last name, suffix, and so forth. Because we know that this is kind of like all characters, or maybe includes junior 1, 2, something like that, and so forth. So these are all alphanumeric values. And for alphanumeric values, there are 3 different data types available. You have char, varchar, and text. Okay, so char is a fixed length string string length. Okay, so I'll show you the example. What's the difference here? But basically, it's you can store up to 8,000 characters, characters for both char and varchar.
Varchar.
Okay, varchar is again, it's varchar, and they both allow up to 8,000 characters, but varchar is variable length string. Char is a fixed length string, and I'll show you what it means by that. Okay, the text is a variable length string again, but it allows up to 2 gigabyte of data, 2 gigabyte of storage characters you can store. Okay, so if you have a big paragraph or notes or something like that,
Mhm.
which gonna get more uh, in length, more than 8 characters, then you probably will allocate text data type. But for name and first name, this can be 50 characters, this can be 50 characters. This suffix is like more like a junior senior type of thing. It may be 5 character. So you allocate varchar data type here. So varchar 50, varchar 5, something like that, to this different fields.
Okay.
Now we are talking about char and varchar, right? So char and varchar. Okay. So if I say char 50 and varchar 50, both will allow up to 50 characters. Okay. But what this one does, let's say our name is ABC. Okay. So even if the name is only 3 characters, it will still allocate 50 bytes. Okay. If your field has a char data type, if you are storing ABC in this field, and since this one has 3 characters only, it will only allocate 3 bytes of storage to the field. So this one is actually variable length. This is a fixed length because it's a 50, it will be 50 byte fixed.
Okay.
It will dedicate for the storage. So
Storage.
that's the reason we typically don't use char. Okay. We use always varchar because we want to minimize the storage requirement. Depending on the length of the field, it will allocate only that much storage to the data elements. So varchar is more efficient if you look at that way for the data storage. Okay, so
Right.
that's kind of like a difference for the storage, and that's why people choose most 99% of the scenarios varchar.
Varchar, right.
Yep. Okay.
All right. So just a quick question. With the
Yeah.
description, I'm kind of confused. So will it still both handle like 8,000 characters? Because it says
Yeah.
length is not okay.
Yeah. So depending on the length you specify, so let's say char, if the field is 8,000 you want to allow, so you just say 8,000.
Okay.
Varchar you can say the same thing if you want to allocate maximum. Now
Gotcha.
here you cannot say 8001. Okay, this one will throw you an error when you try to create a table.
Okay.
It will say, oh, it only allows up to 8,000. You cannot go
8,000.
beyond 8,000. Okay, so
Right.
both will allow 8,000 characters.
Got it.
Now text is a 2 gigabytes. So as soon as you say text, right?
Mhm.
Let's say we are doing, we have a notes here. So notes, we know it can be more than 8,000. So we just say text. And when you don't have to specify text like a 2 GB or anything. This one is by default, it will get 2 GB. And you just specify text data type for the field. Same thing with the integer. So SSN, right? So SSN, we just say int. We don't say int bytes and number of bytes or anything like that, because it will by default allocate 8 bytes or 4 bytes and so forth for the
Okay.
integer field. Only when it comes to char and varchar, you have to specify the length,
Yeah.
how big of the storage you will need. For all others, you don't have to specify. Like a date time and something, you don't specify the length or anything like that. Okay.
Okay.
All right. So let's come here. All right. So those are some of the fields types. Okay. Now there are a couple of more things. Let's say you have certain rules as well. Rules meaning, let's come back here and see if I can. Okay, give me a few seconds.
Mhm.
All right. Okay, so here, this is a primary key, right, in the patient table. Let's come back actually to the drawing board here. Okay, so this is our patient. Patient ID, SSN, first name, last name, and suffix. Okay, this is our primary key. Okay. Now, assume if we are entering somebody's information into the table, assume we created a table and so forth. But let's say we want to enforce certain rules for the data while their user is populating this table. One of the rules says SSN has to be, they have to enter social security number. Let's say this is required. Okay. This one, when we are populating the patient record in this table, patient, if they don't supply suffix, we probably want to enter some default values for suffix. Could be like a Mr. or Mrs. or something like that, or prefix, whatever it is. And so there are certain rules you can enforce, basically, whether the field is required or not, whether we want to insert like a default values and so forth. And these are called typically called constraints. So these are called constraints in the database world, where you can enforce certain rules on at the field level or at the table level. Okay, so there are several constraints available. One of the constraints could be that patient ID has to be unique. Okay, patient ID or social security has to be unique. Because I don't want to enter the same different patient with the same social security number, right? So every time, whenever I create a new patient, I want to put a check in place so that it will check that, hey, is this number unique or not? If it's not unique, then it should throw the error to the user and so forth. Okay, so that's a kind of like another constraint. Then you have constraint called primary key, right? You might have a foreign key constraint and so forth, which checks in another table. Hey, is the key exist in the primary key table or not? So there are various constraints. One of the most common constraint that we use is, let's say we want to insert the patient record, but we want to increment the number by one, patient ID, which is unique in the table, but we want to increment the value by one. Okay, so that's where the identity constraint comes in the picture. Okay, so let's go through those constraints one by one. I just wanted to get you some quick overview, and now let's see what are these different constraints and how we can manipulate, use them in the database. So here, I think this is a page number 4 in your, or 6 in your binder, basically over there. So constraints are nothing but the rules enforced on the data column on the table. So as I said, if you want to make a field required or null, you have a null or not null constraint and so forth. So there are various constraints you can use. These are used to, constraints are used to limit the type of the data that can go into the table. So main purpose is to get the accuracy and reliability of the data in the database. Now, as I said, I mean, certain constraints you can enforce at the column level, certain constraints you enforce at the table level. So what I mean by that is, so when I enforce unique constraint on a particular field, that means it has to scan complete table in order to enforce this constraint, because it has to check against all the other rows to make sure that social security number value is unique across all the records in the table. Okay, so that's what the table level constraint. That's called the table level constraint. But if I say if this field is required or not required, so it's gonna go and validate only against that field when you are inserting the record. So that's a column level constraint at that point. Okay, so that's a little bit different over there. Now, where do you specify this constraint? You specify the constraints when a table, you create a table with a create table statement. Okay, and we will see that how we can enforce or create this some of these constraints. Okay, the most common constraints. Let's take a look at it. So as I said, primary key, right? So this is the most common one. We all know what the primary key is, right? You guys understand based on yesterday's discussion?
Yeah.
Right? It identifies the record uniquely must contain unique values. These are some of the attributes of the primary key. And these are the rules. When you say some field is primary key, it will automatically enforce all these rules for that column or combination of columns that you specify as part of the primary key. So it will identify records, making sure the values are unique. Each table should have one primary key. Each table can have only one primary key, single column or multi-column, which is fine. Multi-column primary keys are called composite key, which we discussed yesterday. Okay, so you can enforce this. You can enforce this constraint on a particular column and mark it as a primary key. Now, to identify required or not required, you can enforce not null constraint. What it says is not null constraint enforces a column to not accept null values. So that means user has to enter some value in order to create a record in the table. Okay, that's what this constraint will do. Without the field value, you cannot insert or update a record in the table. And we talked briefly unique constraint. So all values in the column has to be unique. Now what's the difference between primary key and unique, right? So primary key also has a similar constraint, right? Must contain unique values. So it will do that. So where do you use the unique? So generally, if the multiple columns in the table has a unique values, you can't include and you don't want to include them into the primary keys. So you identify one column as a primary key, and then second column mark as a unique. So kind of like in our example here. So patient ID is unique, right? Is a primary key, but we also want to identify social security number, making sure that it's not duplicate. So instead of enforcing including both columns into the primary key, because it's a mute point, right? Because this patient ID already has a unique values, and you can mark that as a primary key. You just specify the unique constraint on the social security number. Okay, so that's so that you can enforce that rule on social security number column. Okay, so that's you can have many columns, unique columns in the table, but only one primary key. Okay, and as I said, you don't want to combine multiple columns as a primary key. You can enforce these unique constraints separately on the column. As I said, primary key constraint automatically has a unique constraint on it. So whatever column has primary key, it will automatically include unique constraint for that column. Foreign key constraint. So how do we enforce that rule? So you specify the foreign key constraint on a second table, which will point back to the primary key in another table. Okay, so that's what the foreign key constraint is. And you, as part of the relationship, right? Relational database, you know what is a foreign key, primary key. So if I come back here, so major illness ID and patient table, right? So patient ID has a patient ID as a primary key. Major illness has a patient ID as well, but it is a foreign key in that major illness table. So when you create major illness table, you can say patient ID is a foreign key constraint, which points back to the patient ID in the patient table. So you can specify that rule when you create a major illness table. Okay. And we will go through one exercise so that you know. Okay. Check constraint. A check constraint is used to limit the value range that can be placed in a column. So let's take a look at here in our example. Let's see what we can have. So you have gender, birth date, marital status. Let's see. Let's say you are creating a patient value, and let's say we have an age field as well. You know, I mean, people don't live more than maybe 110 years or 120 years, whatever. So you can specify the check constraint on the age, so that it checks the value of age is between 1 or 0 and 120. Okay, so it will, as soon as you input some value, try to store it in the demographics table, it will apply this range. And if it's the value is outside, it will fail the insert or updates or whatever command you are trying to use. Okay, so that's where the check constraint is used. Default constraint is used to enter default value into the column, mainly during the insert or update. And if you do not specify value in this field, it will automatically insert some default value. Okay, so as I said, in the suffix field, we can insert maybe a junior as a suffix by default, whether you supply the value of this column or not. Okay, and we will work through that example so that you will know. And finally, you have identity constraint, and this is important constraint. Okay, often we like the value of a primary key field to auto created value. Okay, whenever a new insert record is inserted. So this can be accomplished with the identity constraint. So you want to increment the patient ID value to 1, 2, 3, 4, 5, something like that for every new record. Then you can specify the identity constraint here on this column, and it will automatically supply the value, next sequential value for the new record that you are inserting. So that's the power of identity constraint. So let's take a look at the create a table so that you know what I'm talking about here. Any question on the constraint before I go conceptually? I know we haven't created much, but I just want to make sure at least understand some part of it.
Oh, I don't have a question.
Good. Yeah, it's okay.
Okay. All right. So let's create a table and we'll enforce certain constraint and so forth. But here is a typical syntax, okay, for creating a table. Now table is also a structure, right? So this is a structure. So this is the command create table, table name. Now table you are creating with the various columns. Okay. So here you have column name. So you have to follow certain syntax here. So what the syntax says is, now within the table, I have different columns. So let's say if I come back to our diagram here. So I have a patient ID, right? And what data type this column will get. And we picked out the integer or something like that for that. It's a number and the constraint name that you want to enforce, okay? And these are the different constraints. So if you want to mark that as a primary key, you just say primary key constraint, and it will take care of everything else. Now, once you do that, then you separate the second column, definition. So table will include something similar to this. Okay, so create table for our purpose, it's a patient, right? And then within that, you will have these brackets. And then you have to specify what are the different fields. So here, I will say patient ID. Now, typically, the definition of the field does not like spaces, okay? But it does allow space. So if you, right now I don't have space, but if you have space in the between the patient and ID, you have to put the bracket around that, okay? But generally, I try to avoid with the spaces and so forth. So patient ID. Now, this is the name of the field. Then what is the type? Let's say I put the integer. And then what it says is patient ID int. Now what constraint you want to enforce? So here I will say primary key because patient ID is primary key. And then second constraint, I want to have identity. And identity has a range which starts with value 1. Okay. So in the step 1. So what it says is starting value of this any record. So if I enter the record first time, it will get a value 1, and then the next record it will increment by 1. Now this number is part of the definition. Okay, so you can change it later on, but it's always good to identify how you want to store sequence the numbers. Okay, so here I'm just keeping it simple: 1 1. Start with the 1, increment the next value by 1, and then comma. So this is my first field value. Then I'll come to the SSN. Again, this is a number. I can do number or I can do varchar. Let's go with the varchar here, because I do want to store some dashes in there. Okay, so varchar 12, and then I want to enforce a unique constraint. Okay, that's all I for this social security number. So SSN varchar 12 data type and the constraint. Then I'll come back to the legal first name. Varchar 50, and let's say I want to enforce not null constraint, something like that. That means I have to insert some value in this field for in order to create a record and so forth. Okay, so that way, so as you see, right, create table patient, that's a simple syntax, but then this one table has syntax for the fields as well, because fields are part of the table structure. So patient ID int primary key, and then I have specifying 2 constraint, this one as well as identity. Then that field definition is done. Second field definition, so SSN varchar 12 unique, that's done. So comma, legal first name varchar 50 not null, comma, and keep on going like that. Okay, so that's how this table syntax works here. So let's come back here, and I have one example here for the patient definition here. So let me, I have a luxury of copying it a little bit. So I'm gonna copy that. And what I'll do is I'll just create a new query window and paste it. And let's see what I have, and see if I can, if it makes sense. Okay, so here in this syntax, I have patient ID int not null. So I'm specifying not null constraint, primary key constraint, and identity. But I'm starting the identity with 5,000. Okay, value of 5,000 here, and then incrementing by 1. So my first record will get 5,000. The second one will get 5,001, 5,002, and so forth. Then the social security number varchar 12 not null unique. So I'm enforcing 2 constraint on social security number field. Legal first name varchar 50 not null 1 constraint. Legal last name varchar 50 not null, suffix varchar 10, but I'm allowing null values. But then I'm specifying default value as a junior. So if I don't supply in my statements any values, it will automatically put default value. And finally, I have age field, age integer not null. So I'm just putting the patient age as well at the same time. Let me get rid of this DBO thing. We don't need that, it's optional. So this is the syntax for creating a table. And if I run that, one more thing. Now you see here on the top. So this is the database selected. Okay. So if I run my statement right now, it will get executed in this database. Okay. Now what I want to do is I want to create my table in the patient registration database. Okay. Now this is a different database. Okay. This is not our database. This is a different database. So what you need to do is make sure you select patient registration database. Master model, my MSDB and TempDB are system databases. You don't want to touch those databases. This is the one that we created. So I want to make sure I select that. So all my statements that I have here, they get executed in this database only. Okay. So that's the important point. So if I execute this, And when I refresh here, table structure, I should see my table here at this point. And if I expand that table and then look at the columns, I will see all the columns that are created as part of my statement here. Okay. Any question? Are you guys following so far?
Yeah.
Okay. But do you guys understand the syntax here for the table creation? I just want to make sure you understand the syntax. So you have create table, then you have brackets, right? And then you want to have field definitions as part of the create table statement. That goes within the bracket, all the field definitions. As part of the field definition, you have field name, data type, and then various constraints. You may or may not have constraint for certain fields. It's not necessary to have the constraint for all the fields. But here, for example, I have included all different kinds of constraint. But you may not specify anything for age. So it will allow null at this point. So I don't have to supply the value for age when I manipulate the record for that table. Okay, that's all it will do. But if I insert some constraint, if I allow or have some constraint, then that means this field will have to have a certain value when I manipulate the data. And we'll see that as we go through that. But hopefully you understand the constraint, and we'll see how we can use this constraint using the queries a little bit further. Okay, so what I want you guys to do is, if you don't have any question, I'll let you guys create the table here, okay? And then we'll do some small exercises so that we'll have further more exercise. But you guys need the table, so I'll let you guys create the table right now.
Now, the table you just created?
Yeah, yeah. And you can see it if you want to see the syntax. I'll leave this page open, or you can copy paste however you want to do it from that PDF as well. It should be fine. But hopefully you understand what we are doing with the syntax. And this is a programming language, right? So you have to follow the syntax. So if you miss like a comma here, you will get some error. Okay, if you miss the comma, and if you try to execute it, you will say incorrect syntax number SSN or something like that. Or if you miss the bracket here, you have comma, then you will see something different, some different error. So you have to follow the right programming structure and so forth.
I'm getting an error messages. Incorrect sentence.
Yeah. Did you? So you have similar to what I have. Can you compare yours with mine? See what mistake you made. As I said, I mean, it has to be very precise syntax-wise. Check the spacing here. If you have spaces in the names, then you will get the errors as well. And most likely, if you are getting the red lines, that's where you're gonna start getting the red lines. Okay. So if I remove that, I don't have any red lines.
So I'm not supposed to get any red line, right?
Yeah.
Yeah.
So compare with what I have line by line. Okay. So create table patient, and then I have bracket. Then I have closing bracket at the end.
So how do I, if I want to delete it, how do I delete them? Like,
Delete, you just select and delete. That's all. Delete on the keyboard.
Okay.
Yeah, select those lines and then press delete and it will remove it.
From the PDF, you see that there's no I don't see the patient's ID on there. Like yeah, this one.
Yeah, it is there. It's just on a different page maybe. So make sure you copy the create table
Okay.
starting from page 7 to 8.
I left that one out there.
Yeah. That's the reason probably you're getting error.
Oh, I think it worked. It works.
Okay, to make sure you see the table on the left side and you will see the columns that you just created with the some constraint. You can like PK is a primary key, integer, data type, not null, all those constraints you should be able to see it on the left side.
Okay.
In the keys, you will see the primary key, unique constraint key will be under keys. And then you will also have the constraint suffix, like default constraint will go under constraints and so forth. Samuel, did you create it? Were you able to create?
Yes, I was able to create it.
Okay. So you both have the table, right?
Yeah.
From
Yep.
that standpoint. Okay,
Mm.
great. All right. Okay, so let's move on a little bit. Um, so once we have the table, now there is a one simple command I want to show you. And let me just type it in here. Select star from patient. Okay. So this select command, we know that is used for reading the information from the table. Okay. As I said earlier. Um, so if I go back here, so we looked at here for reading the many data, right? Any table in table data, you can use the select command to read the information. So this is the very basic command. Select star saying it. What it's saying is give me everything from this patient table. So I can select that and execute. So right now, all it does is it will show me all the column names, but there is nothing in the table because we created an empty table. There is no data populated here. in the table. So that's why there is nothing written. So it just shows us the column names from the table. It's a very handy command. So try it out and hopefully you can see it, similar results. Okay. All right. So let's move forward. Okay, so let's say we added certain things. So we created tables, but we forgot to add one column. So according to our manipulation item, so we can always use create, right? We can drop it for removing the table, but we don't want to drop it. But we want to use basically modify the table structure. So what we can use is use an alter command to modify the table structure. And if you want to alter, let me show you the command here. So alter table, again, the patient table, right? Alter table patient. And then let's say we want to add a phone column with the Varchar 20, which allows 20 characters, and it has a null constraint. So you can use this add or drop. Drop will remove it, or add will add column to the tables. So here we are adding two columns, phone and email. So let me copy these two things here quickly. And what I can do is, so previously I had only this many columns, right, up to age. So in this command, what I'm doing is I'm altering the table patient. Then I'm adding two new fields. And this is the field, this is the definition, this is the constraint. This is the second field, this is the definition, this is the constraint. Okay. So it will add two more fields there. So I'll select those two lines and run it. Because it says command completed successfully. And if I run this select star from patient again, it will show me phone and email column being added after age. Okay. So this is alter command you can use to manipulate or modify the table structure. Okay. So that's a very simple command you can use for manipulating or altering. At the same time, as I said, I mean, you can use drop command. So let me write this command here. So in this set of commands, I'm again using the alter table, right? And then I'm using drop column email. So what I'm doing is I'm going to drop the email column because I don't need it. I by mistake added. So I'll execute this set of commands. It will execute. And if I run it, this select star, then the email column is gone after phone. So it removed the email column. Okay. If you want to try out this command, you can certainly try it out, alter and drop these two commands and see what it does on your side. I'll give you probably another 3-4 minutes to.
So when I tried the select from patient,
Uh-huh.
I don't know why I got an error.
What's the error? Can you read the error?
It's a message 2714 level 16 state 6 line 1.
So did you type in exactly select star from patient or?
Yeah.
This line? Did you have a typo? Is it like a blue, those commands, select and from? There gotta be some typo somewhere. It's mainly the typos that causes you issue, or the syntax. It will cause you issue. But here the syntax is one line, right? There is not much to the syntax. As long as you don't have typo, it should run.
You said there's already an object named patient in the database.
Oh, make sure you select this line and then execute. So it will only this line will get executed. So what it's doing is, if you don't select that, right? Let me run this command. I'll get the same error. This is the error you are getting. There is already object name patient in the database.
Yeah, I think yeah, this is what I got.
Yeah.
So
So
when
make sure,
I
yeah,
select,
because what it's doing is, if you don't select this line and try to run this again, it will start executing command from everything from the top.
everything. Okay.
Okay, so it will try to create the table again, and it says, oh, table is already there, so you can't run this command again. So if you just want to run select star, just select that whole line, like highlight. You know how to do that, right?
Yeah.
Let me know. I'm just selecting this line. It's a mouse cursor thing, and then execute. Then
Okay.
only it will run. Let me know if you are able to run it or not. It should work. I mean, if you
Yeah,
select only that
it's
line.
working now. It's working now.
Okay, great.
Trying the auto table.
Okay,
Yeah, mine worked.
yours work. Okay, great.
Yep.
Let's give a couple of minutes to Bismarck.
Okay, so Asha, I tried the auto table, the add phone,
Okay.
and then when I executed it said command completely successful, but I don't see it like the way you have it at the bottom of the bar.
Oh, did you run the select star from patient again afterwards?
Yes, I did.
Um,
Oh, I should run with this. The okay, hold on. One
yeah,
sec.
yeah. You have to run this command separately. Yep.
Sure. So should I add the select from patient or
Mm-hmm.
should I like to the alter table patient?
Mm-hmm. Yeah, select star from patient separately. So once you execute this command, right, you can run this command afterwards. Okay, separately. So it will finish running this command, and then you can run this command afterwards. So you can see it. Okay, whether the column has been added or not.
Oh, okay, it's working now.
Yep.
Yeah.
Okay. Make sure you run the drop command as well, because that's something dropping the column
So when
email.
you take the email off again, right?
Yeah, yeah.
Let me do that one. Um, I still have the email.
Uh, Run this alter table patient drop column email command. It will drop the column, and then you run the select star from patient afterwards.
Uh, okay, it works.
It works. Okay, great. All right. So as you know, I mean, right, these commands, I mean, you don't have to remember all the syntax, okay? For this alter and drop and all those things. Generally, you can Google it up, and that's what we typically do. But you know how to add a column, remove a column. Those are mainly the DBA level task and so forth. DBA meaning the database administrator and so forth. Yep. So so it's you don't have to memorize everything. Okay, it's depending on what you are trying to do. You just Google it up and basically figure out the command and work through that. But from our standpoint, so managing the structure is less important than actually manipulating the data. Okay, so but it's good to know how to create the table, how to manipulate create the database, so that you can create it from the development standpoint or the QA standpoint quickly, and work with the your next stuff, which is querying the information, populating the data, and so forth. Okay, so we're gonna move on to the next topic. Um, Okay, so as we were saying, right? So we looked at the create, drop, alter, which is dealing with the structure. So it's good that we are able to create the database, create the table, and create the structure. So far, there is no data population anywhere. So that's where we will shift to the, so we are pretty much kind of like done with the DDL statements or DDL commands. But in the day-to-day activity, we'll we probably will use heavily the select, insert, update, and delete for manipulating the data. That's what we typically will do when you are working as a QA or work as a developer and so forth. That's the main work, core of your SQL interaction will happen. So DML command is the one where we will focus on. And we will start with, right now we have empty table, right? So we'll start with the insert command first, because we have to populate the tables. Then we will move on to the delete and update. And finally, the select has a lot more complexity. So we'll keep that for the last. So today we'll cover probably insert and delete. And hopefully if you have time, we'll cover the update. And then next Thursday, we'll cover the select. Start with the select command, which will go on for the next Saturday and maybe next Sunday as well. Okay.
All right.
So it's a lot of complexity in the select command and so forth. Okay, so let's see what we can do with the how do we populate the table that we just created, the patient table. So as you can see here, the syntax is very straightforward. Okay, very straightforward, meaning compared to the select statement, this is very straightforward syntax. So what we are saying is insert into, this is the command. Then what we are saying is what table we are populating the data. And then we have again brackets. And then we are specifying the columns that we are populating. And then in the second line, all we are saying is what values we want to insert into those columns, individual columns. So column 1, value 1. Now this order matters. Okay, so what are the order that you have specified here? You have to supply the value in the same order. Okay, otherwise you will see the values being populated into the different kind of columns. So it will be incorrect from the data population standpoint. So let me just go back to our SQL, right? And I'll start a new query window. Okay, and here I'm going to do insert command. So insert into our table is patient. Okay, and then we have patient ID. Let's see what are the columns we have. So I'm going to come back here, column. Okay, so our column is SSN, legal first name. Now the nice thing about this tool is it will give you some as soon as you start typing something, right? It will give you the matching column, so you can just pick it from there. Legal last name, suffix, and age. Okay, so I'm done with this first line. It doesn't have to be in the same line. Okay, you can have something like this, it's fine. And then you can have something like this, it's fine. It will still work. But for readability purpose and our purpose, I like to separate out the lines, basically, something like this, so that we know what column, what values we are inserting. And let's say we put 1 here. SSN is a Varchar 12, so we have to supply 111, 22, 2222, some dummy number. Jerry, legal first name, Jones, and I'll explain the syntax here. And suffix is senior, and age is, let's say, 40. Okay, so let's see what we did here. So as you can see, I have the patient ID, the first one value will go into patient ID. Then I have a comma. The second value is for social security number, then comma. Third value is for legal first name, then comma. Fourth value is for legal last name, comma. Senior is for suffix, comma, and 40 is for age. Now, one thing you will notice is I have certain values in the quotes. These are single quotes, and the certain values I don't supply in the quotes. Now, what is the reason? Because these are numeric values, you don't have to put the quotes around it. Okay, these are numbers, so you don't have to put the quotes around it. So patient ID is a number, it's an integer. Same with the age is also integer, so I don't have quotes around it. But any char, varchar, text, data types, or date, you will have to put the quotes around it. Okay, so that's the reason you are seeing the values in the quotes. So make sure you specify. Now, if you make a typing mistakes, syntax mistake, obviously you will see the red lines. So you won't be able to run your commands. It will throw you a bunch of errors before you fix it. You have to fix those errors. Okay. So now I'm ready with my insert statement. And let's see if I can execute. Now here I will get an error, and I'll show you why. And I'll let you see why we are getting an error. So syntactically it's correct. Okay. But if I execute it, I'm getting this error. So you have to read there. I cannot insert explicit value for identity column in table patient when identity insert is set to off. Now, can you guys think of it why we are getting this identity error? Remember how we have the column specified. So let me flip back here. So it's throwing the error on the identity columns, which what is our identity column here? Where do we have that constraint? We have it on the patient ID. Okay. So patient ID is a primary key, right? But it's also, we also specified the identity constraint on there. So what it's saying is you cannot insert a value for identity column. Here, what we are trying to do is we have column and then we are trying to insert a value 1. Okay. So what it's saying is whatever column has identity column, you can't put that in the insert statement. You cannot manipulate the value. Okay. And I'll show you the reason why. So I'm going to get you the patient ID column from the insert statement as well as the value, corresponding value. And let's see if we run it. Now this time it ran fine and says 1 row is affected. Okay. So let's see now we'll run the select star from patient command. And let's come back here. And I'll execute. Now you can see it here. Even though I did not insert a value in the patient ID, it got the value as 5,000 over there. Now, why is that? Because we said a patient ID is an auto number. So the system will automatically assign a unique value starting with the 5,000. According to our definition, the first value will be 5,000. The next subsequent records, it will increment by 1. Okay. So if I come, let's say I come here, I run the Jerry 1, Jones 1. Let's say we try to insert a second record. Okay. So I'm changing these 3 values and I'm inserting it. So it says ran fine. The next record will get 5,001, right? The Jerry 1 received 5,001 and the Jones 1, all other data values are there. So this number is being incremented. If I insert the third record, let's go with the 4, 2, 2. It's good. And now if I run it again, now I should have 3 records. Now you can see the sequential value is being incremented. So identity column, you cannot insert the values yourself. System will automatically assign a unique number based on the identity scheme that you have specified. That's the point I was trying to make.
Does it mean the identity, the patient's ID is always on default?
Default?
Yeah, like the machine will give you the numbers itself, so you don't need to put it in again.
Yeah, that's correct. So because of the identity constraint that we included on the patient ID column, this identity constraint, that's the reason it's automatically putting the value, assigning the value for the records. Okay, and so it will always be unique number. So it will not repeat the identity column. So whatever the next sequence number is in the sequence, it will automatically assign that to the next record and so forth. Does it make sense?
Yeah.
Okay, just want to make sure. All right. So that's the purpose. So that is the insert statement. And as you can see, right? Now, if I do this, let's say if I do change Zeri 3, Jones 3, and let's try to run it. Now I'm getting an error here. Now, why do you guys think we have an error here? So it says cannot insert duplicate key in the DBO patient. Duplicate key value is 244. So it doesn't like SSN and the value here, this value for SSN. Why is that?
Okay, so which means that that SSN is for somebody else.
No, this is for SSN. Yeah, but what's the reason why it's throwing the error? Why it's giving the error? So if you look at the definition here, right? So you look at the SSN field definition. So you have Varchar 12, which is good. Value is within to 12. not null, and then we have a unique constraint. So what it's saying is you already allocated this value for some other patient. Okay, so if let's run this one 5002 Jerry 2 already has this SSN value allocated. So if I insert for some other patient Jerry 3 same value, it will keep throwing me the unique constraint value. That means I have to supply the unique, because of the unique constraint on the SSN field, we cannot supply duplicate value. So now I have to supply some unique value for Jerry 3. So now it will be fine. And let's see if I run it. So Jerry 3's record is inserted, right? Because we supply the unique value for social security number. Because of the unique constraint, it enforces that rule. But now here you see it's a 5005. So what happened to 5003 and 5004 is supposed to be sequential, right?
I mean, we did try to put those values in, but they weren't accepted. So like, there was
So
the increment of one added to it.
yeah. So what the identity drawback is, if you had an error, right, in the insert statements, so it will automatically use the number, whether the record is inserted or not. So we had error twice for inserting the record, right? 2004 we had it, and we ran this statement twice, so we got the error twice.
Right.
So it already uses up the numbers. It automatically stores the incremented value in the system, some memory somewhere.
Right.
So the success, so that's why it skipped the 5003 and 4, because it already used up those numbers. It cannot go back.
Okay.
So the next sequential number is 5005, so it will just assign 5005.
All right. And a quick question. Is it possible to correct that, the patient ID?
You cannot. I mean, there is a possibility. You have to turn off the identity inserts, and then you insert the actual value 5003 and 4. But unless you have reason to do that, because you
Mhm.
could have millions of records and millions of, you might have few errors. You don't have to go back and fix those things.
Right. Right.
Yep. Yourself. So yep. Yeah, there is no harm in skipping the numbers. But I just wanted to get you guys an idea why it skipped the numbers.
Got it.
Yep. As long as it's unique, that's all it matters for the patient, and so forth. So it's all good for that.
All right.
Okay. Any question on the insert? Okay, so I got few exercises here. Okay, so let's see if you guys can work through 1, 2, 3, and 4. Yeah, I think there are 4 exercises, and we will stop at the end. I think, yep, for today. It will be 1 o'clock by then. So I'll let you guys work through 1, 2, 3, 4, and try to, if you get an error, read the error, see what you think the error, and we'll discuss. Maybe like after 10 minutes or 5 minutes.
All right.
Okay.
So okay, from 1 to this one
3, 4. Yep.
to 5.
I think it's a 4.
Okay. Hey, actually, a quick question.
Yeah.
Okay, so the first one you did you get a column for a phone number?
There is no phone number here, right?
Because when I did select from patient, I got a a column for phone. I don't know.
Okay. So let me see here. If I run this,
Yeah, I got a
yeah,
phone.
phone is null. Yeah, which is fine.
Yeah.
Yeah. So because you are see you are not populating the value in the phone number here, right? In the insert statement, and it allows null value. So that's why you'll see the null values here. Yep.
Right.
Now, if you want to insert the value, you can always do phone, and after age, you can say 61443331111 whatever.
Okay.
And let's say I run that here. Now I will have the phone number populated for John, uh, basically at that point. The new record will have phone number populated because I'm adding the phone number value as well in this one. Phone number column and the value.
Okay. Thank you.
Let me know if you guys are done or something. Okay,
I'm done.
you're done. Okay.
Yep.
Yeah, are you getting? Did you understand why you are getting the errors?
Yes, I did.
Okay.
Especially with the last one.
Okay.
But I also got an error for the second one.
Second one.
Yeah, I don't know. They said when I tried running it, is it the second one with the name was changed? We changed the name to Do John.
Yeah. What's the error you are getting?
It said, okay, hold on. It said violation of unique key constraints.
Right. So what's the why you are getting that error?
You cannot insert duplicate keys in objects.
I
Deal.
know, but do you understand why you are getting the error?
I think it's the social.
Yeah, social security number, right? Because we have a unique constraint.
Yeah.
So make sure you supply the unique value for the social security number.
So how do I supply? How do I
Yeah,
do it?
instead of 1 1, maybe do 1 9, which you haven't already supplied for
Oh,
the patients. Yeah, patient records. Then run the statement again.
okay. Okay, so the fourth one gave an error. It said incorrect syntax.
Third one or first one?
The last one, the fourth
Last
one.
one, right? Okay, gotcha. So let's see what's the last one is.
Without the H.
So what's the error you are getting?
It said, oh, hold on. Okay, 1 second.
Yeah, it won't be the same error.
It said incorrect syntax near.
Okay, so incorrect syntax is not, so make sure you check the syntax. Are you closing the values properly? You have the commas
Yes.
to this thing, right?
Okay. Virginia in there. Okay. Okay. Okay, it said there are more columns in the insert statement.
Yeah, so what it says is you have 3 columns, or you probably have specified more columns. You have only 3 columns or more columns.
More.
And then yeah, so you need only 3 columns, right, in the exercise. And then you have 3 values, corresponding values that goes along with that. So if you have more, so if I have let's say age here, then I will get the similar more columns in the insert statement than value specified. So make sure you check 1, 2, and 3, 1, 2, and 3 values. The right error you should get is cannot insert value null into the column age. Column does not allow null values. This is the error you should get. Go ahead and if you are still getting the error, go ahead and share your screen quickly.
Okay. Okay. I think. Hold on. I think I've seen.
Go ahead and share your screen. Let me see
I'm
where
using
you're.
different laptops. So.
Oh, I see. Okay. But make sure the syntax is correct. Okay. I think that's you can double check with that and check the syntax. But ultimately, you should get this error: cannot insert value null into column age, because age is we put a by definition we have to have a certain value because we said it's a not null column.
Okay, I think I got it.
Okay. Yep. Okay, that's the reason you're gonna get the value age error in there.
I think I got
Okay,
it.
because it's a not null column. All right. Okay, so I think we are almost at the time. So what I would like you guys to do is, if you guys want, run through the delete statement. Okay, you can insert bunch of data using this type of insert statements. Maybe populate, run this copy paste and run it. Right, that's the first thing. So it will get you some more values to work with. And the second thing would be work through the delete statement from home. There are only 2 statements, right? So if you run the delete statement from the patient where social security number is this, so it will remove one record where the social security number is that. Actually, let's hold off on the delete because I want to go through the how do you do the where clause and what that one is. So yep, so no worries. But you can repeat what you have done. You can drop the database, create the table again, and so forth, and work through those exercises. Okay.
Okay, sure.
Right.
Now on Thursday, what time? What's the earliest time you guys can start? I know regular time is 6:30, but if you guys can you guys start early?
Yeah, me, I get off work at 3:30.
Okay.
But
What about you, Bismarck?
So we can do like 4 or 5. I don't know. I don't mind. I mean,
Yeah. Okay. So 5 to 7, we can do something like that.
we can do.
Yeah, or 4:30 to 6:30, so
yep,
that
that
we
should be
can.
fun.
Yeah. Okay. So let's plan for that 4:30 to
Okay.
6:30, and so that we can wrap up around 6:30. Should be good.
Gotcha.
Okay. And we'll adjust that as we go. And if anybody comes up anything, otherwise we'll see you at 4:30 and use the same link that you guys have for the weekend session.
All
Okay,
right.
it will
Awesome.
work. Okay, I'm not gonna send you separate link. Yep,
Gotcha.
it will work. Yeah.
All right. Thank you.
Alrighty. See you then. See you Thursday. Yep.
All right.
4:30.
Bye.
Bye.